So what we will do, we will start with BGP now.
Yeah.
Okay, we have completed our route filtering. We have completed our IP version 6. Now we'll start with BGP. Now what is BGP? Why we use BGP? Why we need BGP? Why we need external routing protocol? EGP. Why we need external gateway protocol? We have an IGP and EGP protocol. We have studied IGP protocols. Now why we need EGP protocols? What is the use? See, BGP, you can say autonomous system number. What is an AS? What is an AS? AS is a collection of networks under a single technical administration. Okay. And whenever we are inside one autonomous system. IGP operates within the autonomous system. If we are within the autonomous system, we are using IGP. Okay. But whenever we are communicating between two autonomous systems, two AS, then we need BGP. Then what we need? BGP. Okay. So you can say it is used with the service provider. Okay. Service provider uses this BGP. Okay. And you can say unique within the service provider. And the autonomous system, you can say the range of autonomous system that starts from you can give the range of 1 to 65,535. Okay. Now private AS, you can say private AS are some AS that are used. There are two types of AS: private AS and public AS. Private autonomous system used in the same service provider, you can say private autonomous system. Like we are connected, both two companies are connected with the same service provider, unique within the service provider. Okay. Or two branches are connected to the same service provider. Suppose I am having a Reliance service provider and a Tata service provider. Okay. Both of the service providers are different. Okay. My ABC and XYZ are my two company. ABC is connected with Reliance and XYZ is connected with Tata. Okay. So this is something my private autonomous system, unique within service provider. Service providers are unique. We have public autonomous system. Public autonomous system in the sense, suppose I have one branch over here and another branch is in Dubai. Okay. Now I have over here, I have Reliance as is my service provider. But in Dubai, I don't have Reliance. I have something known as Etisalat. Etisalat is the service provider in Dubai. Okay, UAE you can say. Now, how to connect my India branch with the UAE branch? So, ABC customer cities, if they are in different cities, then what we can do, we can have, or different countries you can say, we can have the connectivity. The service provider will have some type of agreement between them that if you want to connect your customers in India, you can connect to Etisalat, and if Etisalat wants to communicate with the customers in India or in Dubai, it can connect to Reliance. This is my public autonomous system. The public autonomous system range is 1 to 64,512. How much? The public autonomous range is, I can write over here. Public AS range is 1 to 64,512. Okay. And private AS range is 64,513 to 65,535. Okay. This is the range. Okay. Now There are some features of BGP. Now, IGP, what is the difference between IGP and EGP? IGP is Interior Gateway Protocol used to communicate within the same autonomous system. And EGP is Exterior Gateway Protocol used to communicate between two or more autonomous systems. Between two or more autonomous systems. Okay. Now there are some features of BGP. It is open standard you can use on Cisco router as well as non-Cisco routers. Then we have exterior gateway. It is an exterior gateway protocol designed for inter-AS domain routing. Inter-AS domain routing. It is classless, means it supports FLSM, VLSM, CIDR, auto and manual summary, all these things in BGP version 4. Okay, there are different versions of BGP. It supports BGP in all these things in BGP version 4. Updates are incremental and triggered, as we were having in our IGP protocol. Some of the dynamic routing protocol we were having, updates were triggered, incremental and triggered. Path vector, I'll explain you what is path vector. It sends update to manually defined neighbor as unicast. We'll see this also. BGP is application rail protocol. It uses TCP for reliability. TCP port number 179 is used. Metric is equal to attribute. What is metric? It is equal to attribute. Okay. Now there are some attributes that consist of the BGP metric value. So I'll explain you what are the attributes in the end of the BGP. When we will ending the BGP, we'll study about the attributes, how BGP calculates the path. The AD value for external updates means eBGP is 20, and for internal BGP, iBGP, it is 200. This is the AD value. Understood? Now we saw over here something known as path vector. What is path vector? What do you understand by path vector?
This helps in loop prevention. This provides a loop prevention mechanism, right?
Yes, it provides loop prevention mechanism.
It tells the previous router S number.
Sorry?
It tells the previous router AS number, like the network
correct.
IP
Not
and
previous
AS.
routers, you are correct. Like I will give you an example. It will also include the path from where it is originating.
Yeah.
So these are my some autonomous systems. You can just see these are some autonomous system. There are some routers inside it. Okay. This is something, suppose AS 100. Okay. This is, you can say, my AS 400. This is my AS 200. And this is my AS 300. Okay. Now, suppose there is a 40 dot network over here. In the AS 400, there is a 40 dot network. Okay. And these are connected with each other. These autonomous systems are connected with each other. Now, what will happen when the autonomous system 400 advertises this 40? Now, how it will advertise? It will advertise over here also, and it will advertise over here also. Correct? Now, when the data is going on to an autonomous system 300, the 300 autonomous system will say the data is originating from autonomous system. It will be having information in the table that the 40.network is originating from autonomous system 400. Okay. Now when this 300 is sending the data to 200, the 40.network to 200. Now over here, the 200 will make an entry that the data is coming from 300 to me, but it is originating from 400. It is originating from 400. What it is? It is path from where it is coming. It is coming from 300, then it is originating from 400. Now when the data is coming to this router, this autonomous system 100, it will make an entry over here that it is coming from 200, then 300, then it is originating from 400. This is something path vector. It keeps the record of the paths, okay, that it is traveling. Now whenever loop prevention means, whenever if my this autonomous system 100 is trying to advertise over here the same 40.network, it will be not advertised. It will be not advertised. It sees its own autonomous system in BGP update. What it will see? It will see over here, it is coming from 100, 200, 300 and 400. So it will see its own autonomous system in the update, that is 400. So it will stop, it will drop, it will not take the update, it will drop the update. This is something path vector, and it will prevent loop. Loop will be prevented over here. Okay, loop will be prevented over here. Understood? Okay. Now, loop prevention we have seen. Now, I told you that the next is it send updates to manually defined neighbor. Now here, what we were doing in our IGP protocols, if we were having some routers, then what we were doing, if we were having two routers, then what we were doing over here, suppose I was having two routers over here, they were connected with each other. Now, in IGP protocol, I was advertising the directly connected network on this and this router, and they were exchanging the routes automatically. But this is not the scenario over here. This is not the scenario in BGP. In BGP, the scenario is different. In BGP, whenever you are advertising any network, whenever you advertise any network in BGP, the routers will not become neighbors. You have to give a manual neighbor command. You have to say, this IP address is my neighbor. Suppose 1.1.1.1 is my neighbor. Neighbor 1.1.1.1. You have to manually define neighbor in. Now here I have defined neighbor with this router. On this router, I have to define neighbor relationship with this router. So I have to manually define the neighborship on each router. On every router, I have to manually define the neighborship. There, your neighbor is this, your neighbor is this. Okay, so it send updates to manually define neighbor as unicast. So now, if this router want to send update to this router, it will only send it at unicast. Okay, it will not send it on any multicast address. It will send it as unicast. Understood? This is something my neighbor relationship. Now, when BGP is more appropriate, when to use BGP? AS working as a transit AS. Transit AS means all the other autonomous systems are connected, are communicating through my autonomous system. That is example in ISP. Okay, all the companies or all the autonomous systems will be connected, all the companies will be connected to the ISP. So ISP will have an autonomous system. It is known as transit autonomous system. So when BGP is more appropriate, when you are a transit, when you are an ISP, at that time BGP is more appropriate. Second, just a second. Just give me a moment, guys. Okay, so first thing, when BGP is appropriate if you are working as a transit AS, example as ISP. AS connected to multiple autonomous system. If you are connected to multiple autonomous systems, then BGP is more appropriate. And when we should not use BGP? If we are using single homed autonomous system, single homed AS. When we are using single homed AS, we should not use BGP. Single homed means we'll study about single homed also, types of ISP connection. Then if you are having lack of resources like memory and less processing power, then you should not use BGP. Like if you are not having a good router, okay, which can not handle BGP configurations properly, then you should not use BGP. Okay, limited understanding about BGP route filtering and path selection process. If you don't have proper knowledge about BGP route filtering and how BGP selects the path, how the packets will be delivered, then you should not use BGP. Okay, so these are the conditions when is BGP more appropriate, when we should not use BGP. Now we have types of ISP connection. Single homed ISP connection. Single homed ISP connection means this type of connection. A site with a single ISP connection. Here what we are having one autonomous system and we are connected with one ISP. One site is connected with one ISP. This is fine for a site that does not depend heavily on internet or WAN connectivity. Okay, either we can use static route over here, we can use default route or static route over here to advertise. Okay, static route or default route or IGP information, we can use anything over here. Okay, so in this situation we should not use BGP. In this type of situation we should not use BGP when we are connected to a single ISP, because we can use default route and static route or any of the IGP protocol on the site router. We can use any IGP protocol to advertise and receive the default route information. Correct? Then we have dual home. Dual home means we are having two connections to the same ISP. Dual home site has two connections to the same ISP. Two connections to the same ISP, either from one router or two routers. Okay, either it will be in this way or it will be in this way. But the ISP will be only one. Okay, the ISP will be only one, either in this way or it can be in this way also. This way. But the ISP is the ISP one only. Both the routers are connected from ISP from the site router to the ISP1. Okay, so dual home site has two connections to same ISP, either from one router or two routers. One link might be primary and the other backup, or the site may also load balance over both the links. Okay, either static or dynamic routing would work in this case. So we can use floating static routes over here, as one as primary and another one as secondary. So we can use floating static route. So here also we should not use BGP, dual homed. What happened? Multi-homing. Multi-homing means it is connected to more than one ISP at the same time. More than one ISP at the same time. See, one router is connected to two ISP, ISP1 and ISP2, autonomous system 1 and autonomous system 2. Now it is done for redundancy and backup. If one ISP fails, for better performance, if one ISP provides a better path to frequently used networks. So this is something used for redundancy. Okay, like this, or in this way, two routers at the company side and two routers at the different ISPs. Okay, dual multi-homed. You can take multi-homing a step further and be dual multi-homed. Like you can connect two links to each ISP from each router. Okay, this gives most redundancy. BGP is used with the ISP and can be used internally also. Now here BGP is being used in dual multi-homed and multi-homed. We can use BGP. Okay, so dual multi-homed, you can see two links are connected to each ISP. If one of the link fails to one ISP, the other link will be up. If the both of the link goes down, or if the ISP1 goes down, we have ISP2 connections. Okay, like this also we can have. Understood? Dual multi-homed. Now we have connecting to internet with BGP route reception options. So we have different options where we are connecting to ISP. Okay, when we are connecting to ISP, we have different option. Either we can have default route from the provider, from the service provider, from the ISP, you can say. Okay, default route, we can have a default route from the service provider. Okay, this, it is easy on resources. Internal traffic routed to the nearest BGP router. Now what will happen, suppose I am having an autonomous system over here. Now I'm running BGP, all the IGP protocol or something. Whatever the traffic is there, suppose this router is connected to the autonomous system, whatever the BGP traffic is there from this router, it will be sent to the nearest BGP connected router, BGP running router. This router is running BGP, so it, all the BGP traffic will be sent to this router. Okay, BGP connected router, so that it can pass the information to one of the ISP. Okay, so default route from providers, or what we can do, an option. Now disadvantage over here is path manipulation cannot be done. You cannot select two paths. Okay, choose the, you can choose the lowest IGP metric to reach the default route. Okay, but you cannot choose the path manipulation, cannot be done. Okay, now second thing, second option is some routes plus default route. What is this? Allows for selection of some paths with other falling back to default route. Now what is this? Suppose I am having some network. What I'll say suppose 10 dot network is there and 20 dot network is there. I'll say for these two I will be using the default route. I'll be using the default route. Okay, sorry, I'll be using some specific ISP. Suppose I'll be using this ISP for these two routes, and for other networks on this autonomous system, I'll be using default route. So what does this mean? This means some allows for selection of some path with others falling back to default route. So I can select some path for particular ISP and the remaining path will be for default route. All routes. Now here I will be having full routing table, full internet routing table at my BGP, at my company side. It is very hard on resources. Okay. Having the complete internet table will be very hard on resources. Okay. So it should not be, it is not recommended. Okay. But guarantees the most direct path is taken. So it will guarantee the most direct path is taken to the destination. Okay. Now here the router needs more processing because the router is connected to the internet and it is getting all the internet traffic, all the internet table it is getting, routing table of internet. So it needs more processing. The router should be very good enough. Okay. Now BGP neighbors are router forming TCP connection for exchanging BGP routes. They are also called as BGP peers or BGP speakers. Okay, there are two types of neighbors now: IBGP, internal BGP, and EBGP, external BGP. IBGP and EBGP. Okay, IBGP and EBGP. Now, IBGP is this. Suppose these three routers are running BGP. These are my IBGP neighbors. These are my IBGP neighbors within an autonomous system. And these two, this router and this router, if they are forming a neighborship, then they are my EBGP neighbor. EBGP, external BGP neighbor. Understood? Between the two autonomous system, they are external BGP, and within the autonomous system, we can run IGP protocol. We can run IBGP. Okay. Now, as we have different types of tables, we have tables over here also. Neighbor table, a list of all configured neighbors. Configured neighbors means, suppose I am having one router over here, one router over here, one router over here, and this router is connected to both of this router. Now what I did, I gave a neighbor command for this router and for this router as well. Now this router will be having a neighbor table and it will be connecting the neighbor list of neighbors, list of all the configured BGP neighbor. So it will be connecting this and this, both of details of the both the neighbors. Okay. So list of all configured BGP neighbors. I need to configure the BGP neighborship. Has to be manually configured using neighbor command. Has to be manually configured using neighbor command. Okay. As I've explained you, we will see practically also. Now, show IP BGP neighbors is the command to see the neighbor table, or you can see show IP BGP summary. Got it? Now we have forwarding table or database table, a list of network known by BGP. Whatever network is known by BGP along with their paths and attributes, it will be stored in the forwarding table. And how you can see the forwarding table? Show IP BGP. You can say this is my BGP table. Like we see show IP route OSPF table. Okay, this is my BGP table, BGP table. And this is my routing table, IP routing table, list of best path to the destination network. Show IP route will give me the routing table. Understood? Any doubt?
No doubt.
Okay. Now, how to configure BGP? How to configure BGP peering? Let us see. Now, the syntax is over here. Router BGP and autonomous system. We have to give the autonomous system. Then network ID and the subnet mask. Okay, subnet mask. Neighbor, and we have to give the IP address of the neighbor, and we have to select in which autonomous system the neighbor is there. Okay, remote AS. Now this remote AS command will give me that this neighbor is my iBGP neighbor or it is my eBGP neighbor. Okay, so we'll see how to configure BGP. Okay, this is the topology. So this is the topology that we'll be using. The same topology that we used. Okay, the IP addresses are pre-configured. You know the IP address scheme also. Show IP protocol. There is no protocol running. So now I'll configure iBGP peering. Okay. Okay. I'll create iBGP peering with any autonomous system. Okay. And all the routers will be in a single autonomous system. And I'll make sure all the routers should be able to see the routes from other routers in the routing table through BGP. So how I can configure BGP? I have to say router BGP. Suppose autonomous system is 500. Okay, 500. Network. Now I have How many networks over here? I have 1 dot network, 10 dot network, and 11 dot network. Now see, whenever you are advertising, now when we are advertising the network, you have to keep in mind that whenever you are advertising anything as /8, okay, like my 10 dot network is /8. So you don't need to give the mask value over here. By default, BGP will take the slash value as BGP will take the slash value as this /8 by default. Okay, like I have in 1 dot network also I have /8. So I don't need to give the mask value over here. But whenever I am advertising other than /8, like my 11 dot network, okay, I have to give the mask value. The 11 dot network is having the subnet mask as /24. So I have to give the mask value over here. Okay, so whenever you are advertising any network other than /8, you have to advertise, you have to also give the mask value. By default, to advertise with default mask value, no need to give the mask. Default mask value means whenever you are giving, suppose there is a class A IP address and you are giving a default mask as /8. So class A IP address is having a default mask as /8. But here I am using class A IP address as 11 dot network, but I am using some different mask over here. So in that situation, I have to use the mask value. What the mask value is been allocated. As per the class, you have to define this. Okay. Now one more network is there. Network 4 dot network is there, which is /8. And now I have to configure neighborship. Now to configure neighbor, I have two neighbor on R1. One is 1.1.1.2, another one is 4.4.4.2. So I have to give a manual neighbor command, neighbor and the IP address 1.1.1.2 remote is 500. It is in the same autonomous system. Then neighbor 4.4.4.2 remote is 500. Remote is 500. No auto summary, no synchronization. Okay. So now on R2, router BGP 500, no auto summary, no synchronization. Network 20 dot network, 2 dot network, 1 dot network, okay, and 12 dot network. 12 dot network with the mask as 255, 255, 255.0. Correct? 12 dot network is there, right? On R2, 12 dot network is there. And neighbor, I have two neighbors now. 1.1.1.1 with in the remote AS 500, and other neighbor is 2.2.2.2 with the remote ASS 500. See, once I make the neighbor command, then once I give the neighbor command, then the neighborship will come up. Unless I give the neighbor command, the neighborship will not come up. So see, once I gave the neighbor command, the neighborship came up. Now on R3, router BGP 500, no auto summary, no synchronization. Okay. Then network 30.network, 3.network, 2.network, sorry, 2.network, and my 13.loopbacks. Then neighbor, I have two neighbor, 2.2.2.1, and it is in the remote AS 500. Then neighbor 3.3.3.2, and it is in the remote AS 500. We are doing IBGP neighborship, IBGP, internal BGP neighborship. See, my neighborship came up with 2.2.2.1. Now on router 4, router BGP 500, network 40.network, 4.network, 3.network, and 14.network with the mask 255 to 55 to 55.0. Neighbor 4.4.4.1 in the remote AS as 500, and neighbor 3.3.3.1 in the remote AS as 500. Okay, now let us go on R1 and check show IP BGP neighbor. It is very long output. So to see a short output, you have to give a command show IP BGP summary. See, these are my two neighbors. And here you should not get this active. This active should not be there over here. So it will go in some time once the neighborship will come up. Show run 5 section BGP. Why my neighborship with this is not coming up? Show IP BGP summary. My neighborship between R1 and R4 is not coming up. Might be the link is down. See, the protocol is down here. Means the R1 side, the link is down, I think so. See, administratively down, 3/. Okay, so what I'll do, interface serial 3/3, no shut. Why the protocol is down? Hello.
Protocol is down for all of them, right? On all the interface, right? Not only on this.
What are you saying?
Protocol is down
Yes, yes.
on
It is down on S3-3.
3/3. I'll delete this link. I'll connect a fresh link. 3/3. Still, it is showing me protocol is down. Yeah, it changed to up now. I think so. See, the neighborship came up now. See, we saw the issue with the neighborship. Always you should get a number over here. You will get always a number over here. How many networks you are been learning from this neighbor? You will get the number of networks that you are learning from this neighbor. Okay. You should not get idle or active over here. If you are getting idle or active something, then it means the neighborship is not properly established. Understood?
where do you see the number 10 network entries? That's what you're saying.
4 networks over here. You are learning 4 networks from this neighbor. See, from 1.1.1.2, you are learning 4 networks. 4 networks means 2 dot network, 20 dot network, 12 dot network, and my 1 dot network. I'm learning 4 networks from my this 1.1.1.2 neighbor. Okay, same over here, state and prefix received. Got it? Now if I go on R3 and if I check show IP BGP summary, see, you can see what is over here. I'm having neighborship with 2 neighbors, 2.2.2.1, 3.3.3.2. Okay. If I go on R1 again, and if I check show IP route BGP, this is the BGP route. Okay. This is the BGP routing table. Now there is no 30 dot network over here. You can see there is no 30 dot network. Is there any 30 dot network or 13 dot loopback?
No.
Okay. Now here is no 30 dot network and 13 dot loopback. If I go on R2 and if I check show IP route BGP, here there is no 40 dot network. You can see. See how it is working now. Now on R1, I am not getting this 30 dot network. Let us not consider the 13 dot loopback. Let us only consider we are having 30 dot LAN only. Now R1 I cannot see the 30 dot network, and on R2 I cannot see the 40 dot network. It will be vice versa. On R3 I'll be not able to see this, and on R4 I'll be not able to see this. Now why it is so? If you want to check, you can go and check on the routers. R3 I have checked. No, R3 I have not checked. Show IP route BGP. See, I'm not having the 10 dot network over here.
This is because we made the neighborship only with R2 and R4.
Yes. We formed here, we are not getting. Now why we are not getting this? See, but we are connected to each other, right? We are connected to each other, so they should. It is not an. It is not an. It will send an incremental updates to the neighbor. Now there is a rule that is known as split horizon rule. BGP split horizon rule. Why we are not getting this 30 dot network on R1? Because of split horizon rule. Okay. Now what the split
Just a
horizon
second.
rule
One
says?
question. One
Yeah.
question. Can we ping or not? From R1, can we ping 30.1? No, we cannot ping because we don't have route.
If we are not having anything in the routing table, how we will be able to ping?
Yeah, sorry.
Okay.
Yeah, go ahead. Go ahead.
So what the split horizon rule says, an update sent by one IBGP neighbor should not be sent back to another IBGP neighbor. What it says, whatever I am sending you, you are my neighbor. I am sending you whatever update, you should not send it to your neighbor. Don't send it to your neighbor. Got it? This is my split horizon rule. It is by default. Split horizon rule is necessary. Why it is necessary? Because to ensure that routing loops are not started within the autonomous system. Okay, so
Sorry, Qayyum, to interrupt you. What I have read in the book, a split horizon will not allow, let's say R2, if I learn R2 route from R1, then it will not send back those route to R1. In case, like if R2 is
R2 and R1 are neighbor. Okay.
Yeah, if R2 is receiving a route for 10, okay, and if a split horizon is enabled, then R1 will not receive back any route from R2 for the same route, same network 10.
See, you are getting confused.
Okay, maybe.
The thing is that split horizon says, whenever I am advertising any network to you, you should not advertise that network to your neighbor. That's it. Simple. Keep it simple. Don't get confused. If this router will not advertise to any other router, how you will get the 10 dot network again? We cannot get. See, you are correct, but you are going in a long way. Don't go in a long way. Understood?
Got it. Maybe wrong. I'm wrong. Yeah.
Whenever I am advertising the 10 dot network to my neighbor, I am telling that I am giving you this 10 dot network. And there is a split horizon rule. Don't advertise this 10 dot network with anyone, with any of your neighbor. This is split horizon rule. So if this R2 is not advertising to R3 or R4, how the R1 will again learn the route? From where it will again learn the route? It will not again learn the route from anywhere. Understood? So it prevents loop. I was telling you it prevents loop. Okay. Full mesh IBGP peering is required now. We require full mesh IBGP peering within an autonomous system for all the routers within the AS to learn about the BGP routes. Okay. So now why we have these restrictions? Now there is no mechanism that you can say to detect and update loop exists in the IBGP. There is no mechanism to update and loop if there is a loop prevent in the loop exist in the IBGP. Okay. Now, what may be the consequences of not having a full IBGP mesh? Okay. You can have black holes and routing loops, update loops. You can have many things. Now, there are different solutions over here. Solutions are, if we see the solutions for split horizon, the first solution is full mesh neighborship. Full mesh neighborship. The second solution is route reflector. Now, full mesh neighborship means I will say I have already given the neighbor command for R2 and R4. I will give a neighbor command for this also, this IP address. Understood? And on R3, see, now you have to learn this thing, that if on R1 I am choosing this path to reach R3's neighborship, see, I am giving this IP address as my neighbor, then I have to use this path only over here. Or when I am giving on R3 as the neighbor command, I have to use this IP address only. I cannot use this IP address on R3 now. I cannot choose via R4. Understood? Got it? So what I will do, I'll say neighbor. I have already given neighbor command over here. Now I will give the neighbor command with R3 also. And here I'll give the neighbor command with R1 also. Same way I'll give the neighbor command over here between R2 and R4. Understood? This is full mesh neighborship. This is full mesh neighborship. I will form full mesh neighborship with all the routers. IBGP. Now IBGP neighbors need not to be directly connected. Okay, this is not the way. This is not an IGP protocol. They don't need to be directly connected, but they must be reachable to each other. They must be reachable to each other. See, my R1 is reachable to this network via R2. They must be reachable to each other. Understood? Now I'll configure the neighborship, full mesh neighborship. How to configure full mesh neighborship? I'll say router BGP 500 neighbor 2.2.2.2 remote ASS 500. Okay. Exit. I'll go on R2 router BGP 500 neighbor 3.3.3.2 remote ASS 500. Remote ASS 500. Okay. Then on R3, sorry, router BGP 500 neighbor 1.1.1.1 remote ASS 500. On R4 router BGP 500 neighbor 2.2.2.1 remote ASS 500. Now I formed full mesh neighborship. Now if I go on R1 and if I check show IP BGP summary, I'll be having three neighbors. I'll be having three neighbors over here. If I see the routing table show IP BGP route, I can see the 13 dot network and the 30 dot network over here. Understood? I can see the 13 dot network, the 30 dot network over here. Now on R2, I'll be able to see the 40 dot network. See, I can see the 40 dot network over here. Okay. This is something my full mesh neighborship, a solution to what? A solution to my split horizon rule. A solution to my split horizon rule. Okay. Now we saw this thing. We'll see route reflector also, the second solution. But before that, we'll go to some more concepts. Like what happens if the link, this physical link between these two neighbors go down? R1 and R2 neighbors goes down and no exchange of routes between them. Correct? Single point of failure. There is no redundancy in the neighbor. If this link goes down, there is no redundancy. Single point of failure. Correct. What is the solution now? What is the solution over here? The solution is, see, these are the loopback interfaces, logical interfaces. So form the neighborship with the loopback interfaces. Okay, make IBGP peering using loopback interfaces. Okay, provides neighbor redundancy. It provides neighbor redundancy because if this link fails, it has another path to reach the loopback. It provides you redundancy. Understood? So how to configure this? How to configure this? Now what I'll do, I'll just remove the BGP configuration, whatever I have done, no router BGP 500 on all the routers. No router BGP 500. No router BGP 500. No router BGP 500. Okay, now we'll configure neighborship with the loopback addresses. Okay, we'll configure the neighborship with loopback addresses. Now we'll say router BGP 500. The command is same, neighbor 12.0.0.1. I can choose any of the loopback. Remote AS is 500. Neighbor 14.0.0.1. Remote AS is 500. Okay, and advertise the network 10.network. I'm only advertising the 10.network. I'm not advertising the WAN, neither I am advertising the loopbacks. Okay. Go on R2, router BGP 500, neighbor 11.0.0.1, remote AS is 500, neighbor 13.0.0.1, remote AS is 500. One more neighbor I forgot over here is have to form the on R2 I have to form the neighborship with 14.0.0.1. Full mesh neighborship. .13. Okay. Now on R3, neighbor, what is the neighbor? 12.0.0.1, remote AS is 500, neighbor on R3 13.0.0.1, not on R3, 13 dot is not there, 14.0.0.1, remote AS is 500, and neighbor 11.0.0.1, remote AS is 500. In network 30.network. No auto summary, no synchronization. Network 20.network. No auto summary, no synchronization. On R4, router BGP 500, neighbor 13.0.0.1, remote AS is 500, neighbor 12.0.0.1, remote AS is 500, and neighbor 11.0.0.1, remote AS is 500. network 40.network, no auto summary, no synchronization. Let me go on R1, show IP BGP summary. What you can see over here, I have 3 neighbors, but the state and prefix learned. What is the state over here? Active. The state is active. Now, whenever you get the state as active, you have to go through some troubleshooting steps. You have to go through some troubleshooting steps. What are the steps? Let me see if I've listed over here. Yeah. Neighbor is peering with wrong address. Neighbor is peering with wrong address. If you get active as a state, the one reason might be neighbor is peering with wrong address. Okay. The second thing is neighbor does not have a neighbor statement for this router. Okay, so we will check neighbor is peering with wrong address. Show run pipe section BGP. So we are having neighborship with this. We are having neighborship with all the neighbor. We are having neighborship, and we are not given any wrong addresses. Neighbor does not have neighbor statement for the router. We have the neighbor statement as well. Autonomous system is misconfigured. We have not configured the autonomous system, misconfiguring it.
Have we enabled BGP on loopback interfaces?
Sorry?
Have we enabled BGP on the loopback interface?
I cannot hear you. Can you speak a bit louder?
Can you hear me now?
Yeah.
So have we enabled BGP on loopback interfaces?
You are saying that have we advertised BGP in loopback in this BGP
Yes.
loopbacks in the BGP?
Yes. Same.
We haven't advertised, but we are not forming the neighborship. See what we are doing. We are not forming the neighborship with directly connected nodes now. So we don't need to advertise the this thing, the loopbacks. Okay.
Okay.
Now the third thing we see is autonomous system is misconfigured. We have not misconfigured the autonomous system. Neighbor does not have a route to the source IP address of an BGP open packet. An extra command is missing over here. Now what is the issue over here? Why we are getting this active state? Now these are not the solutions. The solution is the last one. The solution is the last one. Or you can say the solution is this. These two are the solution. Okay, these two are the solution. What is the issue now? See, whenever I am advertising, this loopback interface is trying to form a neighborship. What it is sending an open sent packet. It is sending an request. You can say it is sending a request to the neighbor. Okay, it is sending a request in the form of open packet. Now when this packet is received, now the R2 knows that I am directly connected to 1.1.1.1. R2 knows I am directly connected to 1.1.1.1, but the packet is coming from the source 11.0.0.1. So what R2 will do? R2 will drop that packet. R2 will not reply with that packet. It will not reply to the open message. So the problem here is with the source from where the open message is coming. the source from where the open message is coming. Now here, when we are advertising the neighborship between loopback, the open message is sent from this source. Now here, if this source is sending the message, then we have to say the R2, we have to update the source. We have to update the source of the neighborship. Okay, so here the issue is the source address. The issue is the source address. Okay. Issue is source address. So when creating a BGP packet, the neighbor statement defines the destination IP address and the outbound interface defines the source IP address. Understood? Because it is going via the outbound interface. Now, when a BGP packet is received for a new BGP session, the source address of the packet is compared to the list of neighbor statements. If a match is found, a relationship is established. If a match is not found, the packet is ignored. So you have to make sure that the source address matches. The source address matches. So what you have to do, you have to use a command, update source command. Update source command allows the BGP process to use the IP address of a specified interface as the source IP address of all BGP updates to the neighbor. Now what I will do, I will say over here, for all the BGP update, my source is this. My source is 11.0.0.1. When it will send, because I have formed the neighborship on R2, I have formed the neighborship with 11.0.0.1. I have not formed the neighborship with this. But whenever R1 is sending a packet without the update source, it is sending this as the source. So whenever my R2 is seeing this as the source, it is ignoring the message. Understood? Whenever it is coming from the physical interface, it is ignoring. So I have to update the source address. So what I'm doing, I'm updating the source address. The loopback interface is usually used because it will be available as long as the router is operational. Okay. Now the IP address is used in the neighbor command and the other router will be the destination IP address of all BGP updates. We use update source command in iBGP. Got it? Any doubt?
Just one question. Why we are making loopback IP as an for neighborship? Because
Just give me a second. Sorry, Pawan, what you were asking?
I'm asking before we formed neighborship on the interface IP, right? And now we are making forming neighborship on loopback IPs.
Yes.
So why we are making on loopback IP? Because it never goes down. That's why.
Yes, if the physical link goes down, we don't have redundancy over here. See, we have two paths to reach R2. We can go via this way and we can go via this way. But what I'm doing, if what I'm doing over here, if I'm forming the neighborship with this interface, it will never choose this path. It will never choose this path.
Okay. This
Understood?
Is different, like
But when I'm forming the neighborship with loopback, okay, now R1 knows that either I can go in this way. If this link fails, I can use this path also to reach the R2's loopback. Understood?
Yeah.
We have redundancy. If we use loopback address, we have redundancy. See, loopback will never go down. If my link goes down, until my router goes down, loopback will not go down. Correct? Until my router goes down, the loopback will never go down. So that is the reason we are forming the neighborship with the loopback address.
Maybe I am asking a foolish question. Again, I asking. Let's say you are going 12.00 from the via R4, right? If in case if link between R1 R2 is down, it is going via R4.
Yes.
The same thing can happen for 1.1.1.2 interface IP also, right?
How it can happen?
The 1.1.1.2, this network IP, this IP or this route is there on R3 and R4 also, right?
I formed the neighborship with on R1. I formed the direct neighborship with this neighbor to reach R2. What is the reason over here? What is the concept over here of neighbor? I have to form a direct neighborship. It will never form a neighborship unless you give the neighbor command. So what I did, I formed a neighborship with this router directly, with this link directly. Understood? With this IP address directly. Now, whenever I want to reach any of these network, I will go via this neighbor only. I will go via this neighbor only. It will never choose other path. Because I am forming.
It will choose other path, right?
In loopback, it will automatically choose. Because loopback is not used in a physical link. Here we are using a physical connection. So if we are using a physical connection, this will be my source. So how you can make this as the source? You cannot make this as the source. You cannot use. This is my source in what? My physical connection. My physical connection. Understood?
Yes, got it.
And in loopback, if I'm using loopback, then loopback can be the source from here also, and it can be the source from here also. Because loopback, we are not assigning to any physical interface. Got it? Pawan?
Yes, got it.
So my solution is update source. A loopback interface is usually used because it will available as long as the router is operational. The IP address is used in the neighbor command, and the router will be destination IP address of all BGP updates. We use update source command in iBGP. Understood?
Yes, okay.
So how to use the update source command? What is the process? Now, how you can give the update source command? Now I have to update the source for all the neighbors. So I will say router BGP 500 and I'll say for neighbor 12.0.0.1, update the source as 11.0.0.1, or I can say update source as loopback 0. Update source as loopback 0. For all the neighbors, I will make the changes. I'll update the source. Done. Neighbor 11.0.0.1, update source twelve dot zero dot zero dot one. Sorry, I have to give the loopback interface, loopback 0. For 13 dot and for 14 dot. Okay, now neighbor 12.0.0.1, update source 13.0.0. Sorry, loopback 0, you can say loopback 0. One neighbor is this, one neighbor is 11 dot, and one neighbor is 14 dot. Okay, here the neighbor are neighbor 12 dot neighbor, update source loopback 0, 12 dot, 11 dot, and 13 dot. Okay, show IP BGP summary. Why it is not forming the neighbor shape? Let me advertise the loopback interfaces. Network 11.0.0.0. Mask is 255.255.255.0. Network 12.0.0.0. Mask is 255.255.255.0. Network 13.0.0.0. Mask is 255.255.255.0. Network 14.0.0.0. Mask is 255.255.255.0. Ping 12.0.0.1. Still I am not able to reach. Pawan, you are asking me if we can advertise the loopback and we can run the things. Still we are not able to reach. See, we cannot reach the 12 dot loopback. There is no connectivity to the loopback interface. There is no connectivity to this loopback. So no entry of this 12 dot, 13 dot and 14 dot will be there. Okay. And what we can do, the issue is the routing table with routing. Now to fix it, we have to configure any of the IGP protocol, RIP, OSPF, EIGRP, anyone, and make sure that you also advertise the loopback interface. So advertising the loopback in the BGP is not the solution. Now what we will do, we will advertise OSPF on all the router, and we will say, we will advertise OSPF. Now these two routers will become the neighbor in OSPF. Okay. Now these two routers will become the OSPF. They will share the routes. They will share all the 12 dot network and 11 dot network. So whenever you are using loopback, you have to use IGP protocol also. So now here I'll be using IGP protocol for connectivity router OSPF1, and I'll advertise all the networks. 10 dot network, 255, 255, 255, area 0. Network 1 dot network and 4 dot network. And it is mandatory to advertise the loopback over here. It is mandatory to advertise the loopback over here. Router OSPF1 network 20 dot network 0 dot 255 255 255 area 0. Then we have 2 dot network and 1 dot network, and we have 12 dot network. Network 30 dot network, 3 dot network and 2 dot network, and we have 13 dot loopback over here. So remember two things, whenever you are advertising the loopback as your neighbor in BGP, you have to advertise all the networks in any of the IGP protocol. Sorry, not one. Here it is 3 dot network. And you have to update the source. Both the thing you have to do. 44 and 3 and 14 dot. Now if you try to ping 12 dot, I am able to reach. I am able to reach the loopback. Now if I see the show IP BGP summary, you can see my neighborship is up. You can see my neighborship is up. My neighborship is up now. What I've done, I have updated the source and I have advertised all the networks in IGP protocol. Understood? If I see show IP, route, OSPF, I can see all the OSPF routes over here. OSPF routes over here, all the OSPF routes over here. Okay. If on R1 I shut down the interface, what is the interface? Interface serial the number serial 3/0. Interface serial 3/0. If I say shutdown, show IP BGP summary, still my neighborship is up.
One question. We are running OSPF here, and the OSPF having all the required routes. I mean,
Yes.
by using OSPF, we can ping any network IP from any routers. Then what's the need or importance or advantage to having BGP in this scenario? We can just use OSPF then. What BGP adding here, the extra feature, or what's the need?
See, BGP is not appropriate within the autonomous system. It is not much appropriate when you are having a single autonomous system. But when we are having two autonomous systems, then BGP is more appropriate.
Okay.
More than two autonomous systems you are connecting.
So in case if we have eBGP or one router as a border router for BGP, then it will make more sense, right?
Yes, it will be more appropriate.
Okay.
Okay. See, I am explaining you from the start, the BGP from the depth. That is the reason we are not seeing the advantages over IGP protocol. Okay. There are IGP protocol we cannot run within two autonomous system. EGP protocol we can run. Understood?
Got it.
Understood this thing?
Yes, I understood.
Any doubt?
No doubt.
Okay, so we'll stop over here for today.